Hi, good morning. Today we are going to continue on with our Common Core Math, and we're going to do section 3.12. This is kind of an interesting section that we're going to be doing today. And our book kind of teaches it to us in a cool way that we're going to try out. And we're going to be talking about the associative and commutative properties with products of fractions. All right, so we have been talking about these famous associative and commutative properties for a while now, and with this time we're going to be adjusting them to use in fractions. So recall quickly that the commutative property looks like this. I can take A times B and it equals to B times A. Kind of like they're commuting to work and back or to school. They're moving around. Remember, I can do the associative property, and I can say that A times B, the quantity of that times C, is equal to A times B times C. And this way, I can choose what is being associated with. And if I combine these two properties together, I can basically move anything around that I want as long as everything is being multiplied. Because if I'm multiplying things, I can switch them around. And if I'm multiplying, that also counts for division, as long as I follow the rules. So what we're going to do is we're going to take a look at some ways that we can do some larger fraction multiplications, but use associative and commutative properties to help us out and make it easier. For example, let's look at example number 1. We're going to find the product of this 6/8 times 1/2 times 16/18. So what we could do is find common denominators and multiply it all out. But the problem with that is it might be a little tricky to find something that's common between all of these numbers. So we're going to use some tricks about using our associative and commutative properties to solve this. So this I can kind of rewrite is really like this. They're all kind of part of the same fraction almost. So I can rewrite it like this. 6 times 1 times 16 all over 8 times 2 times 18. And I could even multiply this out and turn it into a giant problem, but I have some things that I can simplify first that's going to be able to help me out. So now that they're all kind of in one giant fraction, it makes it easier for me to find things to simplify. For example, there was no big numbers that fit into 6 and 8. I mean, I could have divided it by 2 and turned it into 3/4. But instead, I can say, oh, here's a 6 and here's an 18. Even though they weren't part of the same fraction before, they are now because I was able to combine it all into one thing. And I can divide the 6 by 6 and the 18 by 3 and rewrite my huge fraction like this. Let me slide it up a little bit. So I'm going to put a little divided by 6, divided by 6. And now I can even move this divided by 6 over to this 6 using my flip-floppy properties. So I can say I have really 6 divided by 6 times 1 times 16 over 8 times 2 times 18 divided by 6. See how I put my divided by 6 inside? And now I'm just going to choose to do that one first, because I can really choose to do any multiplication in any order as long as it's all being multiplied, and as long as I don't cross this line, I do it fairly. And I could do this one fairly because if I divide the top and the bottom, it doesn't change the number of the fraction. We've been doing that for a long time. So now I can rewrite it like this. 6 divided by 6 is 1 times 16 all over 8 times 2. 18 divided by 6 is 3. Okay, almost done. Let's look at one more. I do see my 16 and 8, and 8 fits into both of those. So I can again divide top and bottom by 8, rewrite my whole fraction over here as 1 times 16 divided by 8 is 2. 8 times 2 times 3 divided by 8. But I'm going to choose to put that divided by 8 over to this 8. 8 divided by 8 is 1 times this 2 times 3. Now I can simplify this fraction out, and it's much easier for me to do in my head. 1 times 1 times 2 is 2. 1 times 2 times 3 is 6. Not quite done. I have to simplify. As soon as they're both even, that always should scream out to me, divide both sides by 2. I can do that. 2 divided by 2 is 1, and that turns into 1/3. And that means that 6/8 times 1/2 times 16/18 is equal to 1/3. All right, so it's a little bit weird with all these simplifying up here and how I did each step, but if you do this, it's much easier, and you don't need to use a fraction as quickly or you don't need to use a calculator as often in your work. And sometimes it's nice to do a lot of work like this by hand instead of relying on your calculator. All right, let's take a look at another one of these problems, and we're going to see if we can simplify it first before we do all the multiplying out. Because if we do the multiplying out first, it turns it into a giant fraction that is going to be hard to simplify. Let's take a look at what I'm talking about. Let's do example 2. We have 9/16 times 1/2 times, let me just check, 8/15. Very small on there. All right, so now I can kind of pretend they're all in one big fraction. And my goal here is to find some numbers that I can simplify this fraction down. And it looks like I see some. I immediately see my 16 and 8 friends again right here. And these two I know I can divide by 8, and I can make it smaller. So let's divide both sides by 8. And we can rewrite this fraction. I have 9/16 divided by 8 is 2 times 1/2 times 8 divided by 8 is 1. And remember, even though I changed different fractions, I didn't change the total value of the product, because once they're all multiplied together like this, I can do the same thing to all of them and it doesn't affect the answer at all. Okay. Almost ready, but I see another thing that jumps out at me. I have a 9 and a 15, and I know that 3 fits into both of those. So I'm going to divide both sides by 3, and I can rewrite this section of fractions below. 9 divided by 3 is 3, so I can write it as 3/2 times 1/2, can't simplify that one, times 1/, and now I can do my 15 divided by 3, which is 5. This fraction is way easier to work with. What's something that's weird that I just noticed? Look, this is now an improper fraction, and it wasn't before. Does that mean I did something wrong? No, actually not. Because remember, I'm not looking at any individual piece of this fraction. I'm looking at the whole setup and how it is. So I know that even though this one, 3/2 is very different than 9/16, the whole fraction is still equivalent. So now I can multiply through, and I just have to multiply my numerators, and then multiply my denominators. 3 times 1 times 1 is still 3. 2 times 2 times 5, well, that's 2 times 2 is 4. 4 times 5 is 20. All right, can I simplify this down at all? Well, they're not both even, and I can't fit 3 into both. So I am good to go. All right, so sometimes this section is going to be asking us to simplify things, and we will need to use our commutative and associative properties to move things around. For example, what if we take this one? We have quantity x times, very small, 4/5 times 1/2. All right, well, my normal PEMDAS rules dictate that I have to do this inside part first, but I can't simplify x times 4/5 at all because, well, I don't know what x is, and I don't know what 4/5 is, so I guess I'm stuck, right? Well, no, because we can use our associative and commutative properties to just change around the order that we want. So I'm just going to move these parentheses to the other side. I can write it like this. 4/5 times 1/2. Oh, well, now I can simplify it, because I can get rid of these numerical terms and still leave my variable outside. Okay, so let's do 4/5 times 1/2. That's pretty easy. 4 times 1 is 4. 5 times 2 is 10. I have x times 4/10. But I should have noticed these are both even. I definitely need to simplify this. So I really have x times 2/5. And this is, remember, simplified, because we started with an expression and we simplified it. We were not able to solve it because this was not an equation. There were no equals in it. Now, certainly I made one when I was doing over here, but that wouldn't be useful to help us solve it because we were given no equal sign in our original section that we were working on. All right, if you feel like you understand it, go ahead and go on. I do want to see some steps. I'm going to do another example with kind of the large... I'm going to do another one with our variable that we've got. Okay, let's take a look at this. And this one's going to start like our one did before, and it's going to say 6/7 times x times 1/3. Now this time, just like we used the associative property last time, we're going to use the commutative property. And I'm just going to move the x in the 6/7, and I can rewrite it like this. 6/7, oops. I'd rewrite it like this. Let's try again. X times 6/7 times 1/3. Oh, well now I can do that. It's pretty easy. X times 6 times 1 is 6. 7 times 3 is 21. I believe that I am simplified. Oh, I'm not. I can divide by 3 into both. 6 divided by 3 is 2. 21 divided by 3 is 7. So I really have x times 2/7, which is my simplified answer. I could also have 2/7 times x. It doesn't really matter. We just, often we actually put the numbers first, but it's up to you, and it doesn't matter at this point in the game. All right, that's pretty much all the things that we do, and awesome. Good luck, and go on.